just get people viewing it in the end or later on
Um,
after the broadcast?
it's a little mix, So we are officially live here, Yeah, this is my second one right here. So last week was I had Otavio, and we were talking
Mm-hmm.
about what it means to be like a craftsman as a developer.
Mm-hmm.
Particularly trying to gear my podcast a lot towards freelance developers and like
Great.
developers that are kind of like cutting their teeth on their first project and
Mm-hmm.
don't really know where to go. They're looking at like they're having to make architecture choices that
Mm-hmm.
they didn't necessarily train for or study for, because it's like
Yeah.
you learn the programming language, then you learn a framework, and then you start trying to develop your first project. And then you end up learning you got to learn 2 3 other frameworks and a
Mm-hmm.
database and all this stuff to kind of go together with it before you're actually like effective at doing something. It's not like
Yeah.
you can just learn a programming language, and a lot of people feel like that's kind of where it begins. Like, oh, I learned Java or I learned JavaScript or whatever, I'm a developer. No, not
There's lots
really.
more. That's lots
Yeah,
more. Yeah.
I
I,
wish
I
it was
keep
that
telling,
simple.
I keep, when I did, so I did a workshop like pre-pandemic. I did a workshop. I had the good fortune to do a workshop on DevOps UK. If you know,
Mhm,
DevOps used to be a primarily Java-based conference, but
mhm,
these days it's doing web and lots of other cool stuff, not just Java. It's everything
mhm,
you need to learn. A developer needs to learn. So I got to do this workshop, which is again not specific to Java, but has to do with programming and
mhm,
coding, and just similar to what you're talking about. And in my workshop, I say there are three layers, right? There's
mhm,
the technology domain. That's one layer.
mhm,
There's the business domain. There's the second layer. Of course, there are other names to these layers, but there's a layer in between that weaves the business domain with the technology domain, and that's the methodology domain. You can name it something else if you want to, but it does not change its
mhm.
function, its purpose. And so technology domain is where we're talking about Java, web. Hey, EL.
Hey, yeah.
Hello.
Yeah.
Yeah.
So I was saying technology
Hello.
domain is where Java, all the technologies we talk about, everything we learn, frameworks and all that stuff you
Mhm,
talked about. Business domain is not where we really specialize in. We
mhm,
learn that from our workplace or from various experiences in our business, in our work experiences. And
mhm.
that's where we need to deliver, because nobody cares whether you use Java, JavaScript, or one line of Bash. The business cares is my customer able to use this, get value from it? Is the problem solved, by
Mhm.
whatever you IT guys or engineers have been doing? But they also don't care. Of course, they do care, but they don't really care what methodology did you use to weave the technology to deliver the business solution. Did
Mhm.
you understand the business domain? And how did you do it? They don't care about that, but they do care about it, because in the end, if they don't care about it, then the end business result is not great. So
Mhm.
craftsmanship is a methodology, agile is a methodology, pragmatism is a methodology, you name it. And they are not technologies, they are not the business domain, they're not technology domain, they're methodology domains. And
Mhm.
so if the three are not woven together, and this is what I was bringing in my workshops. Unfortunately, I cannot share a lot of that material online because it's workshop material. But
Mhm.
in the workshop, I make it clear. And in other presentations I've done, I've also shown this. There's a business domain, there's a technology domain, there's a methodology domain, and there's a weaving between the three.
Mhm. All right.
If we
So
don't
since we,
master them, yeah, let's
yeah,
get started. Sorry,
yeah, let's get started. All
that was a
right.
little
So,
tangent from what we
um,
are here for. Sorry
yeah,
about that. But over
yeah,
to
a
you,
little sneak
Jonathan.
peek. All right. So, I'm Jonathan Cruz. I'm a software developer. Been for some years. I specialize pretty much in Java, Spring Boot, and I also work on Mean and Mern stack applications. And we have here with us Manny and Eyal, and they are AI experts. Yeah.
Wow.
I'm honored to have y'all here with me. I
Thank
feel
you.
like I'm a little fish in a very big pond, and y'all are some of the
Whew.
bigger fish. So I'm hoping y'all can educate me on some stuff with AI. If y'all would like to introduce yourself, many of you would like to start with you.
Yeah, sure. So my name is Mani Sarkar. I'm polyglot engineer. I call myself these days because I started off doing a lot of Java, but whilst doing Java, I also learned that there are other programming languages that work very well with Java, and the industry out there uses other languages as well. So I write code in Java, Python, Node.js. I mean, whatever tool is needed to solve the solution. And I've broadened myself from just doing software engineering solutions and software engineering projects to also doing data and machine learning alongside. So basically, projects that where data meets machine learning meets software engineering. And yeah, so hence we are here. I'm not sure if we are big fishes, but I think we are pretty much similar fishes from different perspectives.
Yeah.
Over to you, Eyal.
Yeah.
You
My name is Jayal Birzyansky. I have been a Java developer for many years. I've been running the Java user group in Jacksonville, Florida, for quite a few years. But recently, I went back. I became a data scientist at work, which is going back sort of what I used to be when I was at school many years ago, and that was doing AI and machine learning. And I have been doing that while I was doing Java. I was doing that as well, but more in the community. And I have a website called AI for Java. One of the things that one of my main passions, and I share that with Mani, is helping people do AI and machine learning in Java, because Java is not the language of choice. It's not the language that has the most tools to do that. Python is, for example, or Python is the best example of a language that has everything you can think of. And I now also use Python at work, and I've been doing stuff in Python as well. But I'd like Java people to also be able to do that. And there are actually a lot of companies that are Java shops. And over time now, especially in the last few years, machine learning and some other AI aspects are going into all kind of products. And if you're a Java shop and you do everything in Java, it's preferable usually if all your people are Java, all your DevOps is Java, or it's preferable not to introduce another language. So a lot of things can be done, most things can be done in Java, and that's sort of what I would say sort of my specialty, or something that I have been into for a while now.
Okay. Thank y'all for your introduction. Again, I'm definitely honored to have y'all here with me to answer some of these questions. All right. So again, like one of my main focus is for the freelance developer, contract developers. Matter of fact, I was just in a call earlier today talking with a potential I guess hiring manager about a particular product, and they were using the term AI in this thing, and I was like, well, is it really AI, or is it something that's kind of simulating the feel of AI? Like a basic like logic tree or something like that is kind of going through some known if this that then going filtering down. And that's really what it was. They're like, well, we really wanted to go into the AI space and all. But at that stage right now, they're like, no. And they're like, we want to call it AI, but we really can't. They're kind of there. And I'm like, this is constantly popping up now. Like it's a coin phrase that everybody wants to use, especially like these smaller companies are wanting to use it. So investors want to, oh, you're using AI. It's great, and so I feel like they're starting to abuse the term, honestly, and they don't really understand what the tool is used for and all. So I'm going to kind of come at it from that perspective and from a person who has very limited knowledge and understanding of AI myself. So that's why originally I titled this "What Road Should Lead to AI." Because that's the one of the number one questions I'm hoping we can kind of answer here. I know there's always these edge cases in this, but for the most part, what is AI really meant to solve? And that's my opening question: is what is the main problems that AI is actually meant to solve? So.
So I think that's a great question. Eyal, do you want to take a quick jab at it, and I'll support it with additional things.
I don't have a great answer, because it is true that AI has fuzzy borders. It is easy to say this is AI, and it's hard to sometimes say that it is not AI, because there are things that are more complicated and less complicated.
Mm-hmm.
So there's sort of a joke that says that when the company raises money, they tell people that they do AI, and then when they actually hire people, they tell them that it's machine learning. When they actually do the job, it's linear regression. So it becomes less and less glamorous. But linear regression is still machine learning, and machine learning is still part of AI. So you can still call it AI, but if you don't do any of the above and you basically have some rules that says, or even if you have a rule engine, you can still call it. So, but there are things that have been done traditionally, not with machine learning, and now machine learning is taking over. So you can maybe put time there, but regardless of that, if you ask what AI is meant to solve, I don't have a good answer, because there are many different areas that AI found its way into, and it can potentially find its way into many others. So I'm not sure that I can say that it was meant to solve several things more than others, but we can look at the things that where AI is doing is more maybe found more abundantly, rather than other areas where maybe it's still not successful enough, or it's too much work, or it's not a commodity. Now, in areas where AI have been going into, think of recommendation engines there, for example, they're everywhere. So there are usually tools and techniques, and the good thing is in areas like that, developers in many cases can use it without needing to know very in-depth what's behind it. They can use tools. The tools will do a lot of the heavy lifting, but you need to know what it is, how it works to some degree, how to use the tool when it doesn't make sense, when basically the results that you get, you need to have a way to basically monitor yourself and make sure that it's actually doing the job, and it doesn't after a while. Maybe sometimes it can start, looks like it's doing the job, and after a while it doesn't. So a lot of it nowadays is also a matter of operations or ML ops, the DevOps. But when you get started, you basically need to see what problems it can solve for you, and there are many resources for that can tell you use cases and things that tools that exist, etc. And then see how you can fit it into your software, which requires a little bit more maybe specialty, but you don't anymore need to be a particular AI expert or even an AI person. You just need to know enough about it, and I think this is sort of also what Manny and I are into, trying to spread the word of the community and get people to understand the basics so they can become. Sometimes we call it citizen data scientists, meaning they don't have to be experts, but they can do this in their field using simpler techniques or using out of the box that they can know enough about.
So I mean, to answer that question, just like any invention or creation, when it happens, it's automatic. It's like a eureka moment, and nobody expects it. Nobody looks for it. But I think if you go back and if you even look at sci-fi and TV shows of the past, the things that were really visible at that time, because the computer was the only thing that was mainstream, right? Because you had television and all those things, you cannot interact with them the same way you interact with the computer with. But AI, I think at that time was developing to make your computer and your computer programs smarter and more intelligent, right? Eventually, it so happened, okay, we'll make a television smarter, a microwave smarter, a fridge smarter, because computers started getting, implemented or becoming fused into those technologies as well. And so AI went along with it. So the idea I'm getting is AI in general, or at least unknowingly, was used to make our programs smarter, computer programs smarter. And if you see immediately, the applications came very, very much into computer games, right? People were making computer games smart, and you saw AI immediately there. Later on, then you had things like ELIZA. If you know I think it's MIT that did the experiment of creating an electronic psychologist that would talk to you, but it would use your sentences to create sentences, and it would make it look like, if you look at the ELIZA program, it's like how Eyal was saying, it's only ifs and thens. And
always
so,
ask you a question.
yeah,
It never tells you anything. It just keeps asking you questions. But I found
exactly. I mean, I can share a link of Eliza because I've written a small application called Conversational AI, and you can see some examples of how I've done it. And you can see that, and I've implemented it in multiple ways to only show that you can, like, make it look like, you can make it look like we are having a conversation, but in a sense, it's actually using the same words in a very smart way. So I'm just going to share that link here. It's called Chatbot Conversations, and Eliza is one of the examples in there. So I'm also going to point out to that. So, and it was just an experiment. People were trying to play around and see, can we make computer systems smart? And if we did that, what would it look like? And can we emulate human intelligence? And so on and so forth. And as things went by, people were noticing that actually this is an emulation of of human intelligence, and it's not really the full human intelligence, right? That's why there's this conversation called artificial general intelligence or artificial intelligence. Then there are some people who call it artificial neural intelligence. So I think this happened just as an accidental experiment. And then they saw, oh, but we could do a few of these things and the world wouldn't know what we're doing, but would end up making things look smart.
Yeah, making it look smart. Yeah.
Yeah. So, like, for example, as Eyal was saying earlier, when you say artificial intelligence, if you look at the real old books of artificial intelligence, you will see there's a lot of if-then, like a lot of programs, big programs with a lot of nested if-thens, and it checks if A is greater than 5 and B is less than 6, then do this. So basically, what people did is they did research to find out what are the boundaries of values that we need to check to make sure that we end up creating something that will make it look like it's emulating something from the real world, but actually it's not. We're just using numbers and controlling numbers and checking numbers and making and it makes sense as well, right? For example, if the temperature of the room goes above so much, then do something. If it goes below so much, do something. And if it repeatedly does that, and you have some cues of like within this range, do this, within this range, do this, and it smartly does that. Like, if the temperature goes above 50, open the windows. If it goes below 20, then shut the windows, those kinds of things. And if it can smartly learn and do that, and every time it goes 29 or 58, then it does something similar, then it makes it look like, there's artificial intelligence here, right? But it's actually just logistical
Yeah, I like how you said
regression.
there's knowing the range of the parameters of the values, basically.
Exactly.
Where
That's
the key can happen.
That's
from.
the key. That's the key to it. Yeah.
Okay, so I guess that would
please. Yeah, go on.
probably lead us into the next question I had. Then is because I know when I was first getting introduced to the concepts of AI and stuff like that, right? It's like you think that like, oh, there's AI and then there's machine learning and then there's like neural networks and all. And then I got a little farther and realized, oh, these things are nested kind of inside of each other. And so then that brings me to this question here. So within AI, we have machine learning, artificial neural networks, and deep learning. Do we need all or any of these to implement AI in our application? Now, based on some of the stuff that you said, I could think I could answer part of this myself now already, that we wouldn't need machine learning or artificial neural networks or even deep learning to do some of this parameterized, like if else then conditionals that would simulate intelligence. But how would y'all answer this? Eyal, what would you say?
So I would discount now. I would think that if then else, etc. Let's not call it AI any longer.
Okay.
Let's look at AI as or let's try to redefine it in a way now.
Okay.
So first, within AI, the main branch or the main field nowadays, I believe, is machine learning. Machine learning has a lot of different algorithms and several different types of machine learning. Supervised machine learning is probably the most common one, but within that, you can say that neural networks are one of the main architectures. Algorithms. There are many different algorithms of neural networks, But one way it leads to is what we call deep learning. So deep learning is actually a kind of machine learning that utilizes certain kind of neural networks as the main algorithm, the main architecture. Sort of outside, but overlap is what I would call another, I think, field that is sort of large and is gaining is the natural language processing, which I think Mani knows a lot more about it than me. But also in this field, there is a lot of use done with neural networks. And now we sort of, I think, is starting to use some of these techniques actually for image processing and things that are more like deep learning, classic deep learning things. So natural language processing overlaps to some degree with machine learning. And then there are things that are not exactly either. I'm finding it a little bit difficult to call it a name, but for example, one of the things that I specialize in is genetic algorithm, and genetic algorithms are a way to solve different kind of problems, but there are all kind of other methods to solve such kind of problems. And think one kind of these problems is called a constraint problems. It's hard to give it a good name indeed. It doesn't sound so great, but think of problems like if you have the Amazon delivery cars and you have to plan a route. You know that you have to deliver a package in several places, and you have a fleet of cars, and you want now to figure out which car should go where and in what order, and you want to minimize your gas costs or whatever other costs that may be involved, or you have some other constraints about when you can actually deliver each package. How far the car can go. Think of it, if you have a drone that goes, the drone can only go half an hour before you need to replace the batteries. So can you find a place where you send all the drones? Think of scheduling problems that are very common. Scheduling of classes in class, scheduling of rooms in a conference, scheduling of people to do shift work, like nurses in a hospital or people working in a restaurant. And each one has constraint. This person cannot work in this department, or in this department you always have to have 3 people working, and it can only be these particular people. This person maybe want to be on vacation. So solving these problems in general is also part of of artificial intelligence. Generally, it's considered. So there are different algorithms to do that. Genetic algorithm is one particular method, and there are many others. So there are some interesting tools, but it's a little bit less glamorous nowadays because this have been around sort of a steady thing, and machine learning and deep learning came to the front recently, and then some aspects of natural language processing came even, and they sort of overshadow other things. So I heard actually somebody says artificial intelligence is machine learning, and actually everything else is just a buzzword. But I think there are other things other than machine learning, the things I mentioned, maybe others that I didn't mention and I can't think of. There are other things other than machine learning.
Yeah, I think Eyal actually pointed out a very interesting thing, which brings me to this is actually artificial intelligence is a bunch of algorithms, right? Because if you see that if then is basically an algorithm, right? And all the other algorithms like genetic algorithm and all the other techniques are also more sophisticated ways of molding those if then. So it's not always if thens. You compute, you do mathematical computations, and optimization problems are also like all the algorithms that came out of solving optimization problems and solving constraint problems are also adding intelligence to your solutions, right? So business has been doing this, or research or science or whatever field you want to call it, has been doing this, developing these algorithms for years, for decades. They just don't give it a name because those algorithms have powered the applications to deliver something that human beings couldn't do it very efficiently, right? Because so many variables needed to be kept into check, right? Just like the delivery component that Eyal mentioned from the Amazon world. I mean, there are so many moving factors there. Some factors play a role, some don't play a role. Then there are hundreds of these features that bring up values that needed to be optimized to get a final value of delivery time, right? And delivery date and things like that. So, and the other question you had, what do you use, AI or machine learning or deep learning? So I look at it like this. The way they are nested is because they're getting evolved. You see, initially we had algorithms. Initially we had hierarchical trees, and we just called it artificial intelligence, right? But as tools, technology, and research developed, we realized that actually we could develop algorithms that could take all of the data that we have, run through that data, and the algorithms would study the movement of data and its relationship with the result we want, and can come out with certain kinds of numbers, and then we can use that as an equation. And then any new data that we get, we pass it through that equation, and we get a final answer, which is fairly close to what the real world answers would be, because you see it's adjusting all the features with the data, and then it's coming with the
like
target.
Intelligent guess.
That is machine learning, because the machine is learning the data. You see? So previously we manually wrote the program, right? If A is equals between 5 and 6, then increase B. If B is between 5 and 7, increase C. And finally the target is D, which is 10 or something like that. But and that's why those programs are huge. Today, if you take a machine learning algorithm and you convert it into code, you'll get this huge nested tree of those if and then. And I mean, that'll be if you're using logistic regression algorithm, right? If you use another algorithm, you'll get a whole complex set of program that is taking these values, taking each of those values and hundreds of values, and finding an optimized equation into which it can input these new values and get a final answer. So that's machine learning. Now, the next level is deep learning, where it's not using this concept of optimizing into an equation. Rather, what it's doing is trying to emulate how our brain works, which is neurons. Neurons connect to other neurons. Neurons fire and connect with other neurons, which fire another. And there's cascades and layers of neurons, right? What it's then doing is then it's taking the same machine learning data and machine learning problem, and now it's trying to propagate that through layers of neurons, not through finding an equation, right? Not to finding a super.
So you're saying it's distinctly different.
Yeah.
One's not leading into the other one. It's a different approach to solve the problem.
It is an evolved and advanced approach to solve a problem. So the way I actually explain to people to keep it simple is AI is where you manually write the program. Machine learning is where you got the data and you got some program, and you create a new program that is embedding the data into the program, and it's a new program that is married into the data, but it is static still, because it's bounded by the boundaries and the domains of the data you fed it, right? Because it cannot create a new stuff from that data. That program is static. That model is static. Unless you train a new model, that program is static. But deep learning takes it further. You can create a program using data, just like machine learning, but that program is now more dynamic, because you can retrain it, and it can also learn new things from the things about the data that you haven't told it yet. Because in machine learning, you got to tell, these are my features, this is the target. If you don't tell it new features, it doesn't know about the new features.
So with the neural network, is it a constant stream of new data into it as well as like the old data, or do you specifically like feed it incrementally new data to change the model when you're ready?
That's a very good question, because if you create a machine learning model, again, this is very subjective, because sophisticated new techniques have allowed this to change. But if you have new data, you have to create a new machine learning model. But of course, that can be changed. People use ensembles and other techniques to override this, and I could be quoted wrong. But neural networks are specially such that you can layer data over learning over learning over learning over learning. It'll keep adjusting the weights every time it learns new things, and it will increase the network, and you can go complex with that, which is not the case with machine learning. It's not the case with machine learning.
Does it adapt in real time, or is that something?
Well, you can make it such that if you have new data and you have a model, you are on the fly building a new model using the old data model, and you're creating a new model, and you put the old model offline and you bring the new model online based on the new data you collected in the last 24 hours, right? This is one way of doing it. You can also do it streaming, like where you every data that comes in, you create a new model, but that's too expensive, right? Because building the model takes a long time. So you would then have to batch your models in 24 hours, 48 hours, or 1 week sessions. Again, what I'm talking here is also subjective, because people are using different techniques to do different things. But the idea here is that deep learning networks or neural networks can be layered. So you can learn that. That's what the technology terminology is. You can learn when you have new data, and then you can keep piling layer after layer, and your new model will be better or different than your I mean, better is subjective, but new model will be based on the old model, but new data.
So
Whereas
are there
with
certain
machine learning,
challenges?
it's different.
Are there certain challenges that machine learning would be a better solution for over the neural network, or is neural networks like good enough or better that we don't need to do old machine learning techniques? Like, can I just not learn machine learning and jump straight into the neural network?
Interesting. This is an experimental phase. A lot of times we use both these algorithms. We use the same data. We transform the data for both these types of techniques, for deep learning and machine learning.
Okay.
And we see which one is producing better results over time. But there are some types of problems that are better solved. Like, for example, if you want to have a continuously incrementally rebuilt model, machine learning is okay to do it, but you'll find it'll be constrained because you see it creates equations that are static in nature, which cannot be extended very easily. Whereas with deep learning, as you already seen, it's layer based. The neural networks can be increased and decreased. They are dynamic. They can be made dynamic. Well, they're not dynamic, but they can be created in such a way that you can just layer them one on top of the other. Again, what I'm saying is very general, but it's more flexible than doing it with machine learning algorithms and machine learning techniques.
So correct me on. So taking what Eyal said, some of the examples he gave, like one is like the routing thing, the Amazon routing. So to me, that would seem like the deep learning solution would be good if the routes or certain variables never really change too much. Like if like the streets all stayed the same. Whereas though we know like traffic accidents and other things happen in real time and all, or construction, actually probably construction would be something you would want to respond to because construction tends to last weeks, not just momentary. So then the neural network would then be able to adapt the routes, if I'm understanding this right, would be able to adapt to that, knowing that there's going to be construction in this particular area. It's going to slow down this route. We need to adapt to a different route. Whereas in the machine learning approach wouldn't be able to immediately adapt to that. Am I understanding that correctly?
So it's not fully that way. Also, Eyal, do step in if I say something that might not be correct because I don't want to mislead anybody and I still want to stay general. So you can solve the same routing problem using both solutions, and sometimes it's able to solve in both. You got to understand here one thing is that with machine learning, you got to specify the features, meaning what are the components and parameters and variables. Whereas with deep learning, the algorithms figure it out. You give it the data, and it figures out more features that are hidden in the data, which machine learning doesn't do. Machine learning,
when we define feature on our route example, right? What would be considered a feature of a machine learning?
All the parameters you know that make up the routing the solution. For example, let's take a very simple example. You have a fruit. It's got color, size, weight, maybe shape. And can you convert them into digital values? Yes, you can. You can. Okay. Those are the features of the fruit. Now, once you have that, you can say, okay, if it's like an app, okay, if it's curved, it's yellow in color, it's weighs so much, between so much, it can be a banana, and so on and so on, and orange. And of course, if there's a picture with it, you can convert the picture into digital values. And again, this is subjective because this is not how you
look for similarities in
exactly. So those are the features, and then you map it to a number, like or a name. Right? And that is your machine learning problem. Whereas with deep learning, you take all of this data and you give it the data, and of course you give it the label. It will figure out more hidden values that you've not given it, because those are the interactions between those features and between all the data you've given it. Because you see, if you have millions and millions of rows of data describing different fruits or components or elements or routes, there are lots of things that are happening in there that you don't see as a feature. As a human being, the algorithm goes and figures it out.
It's better at recognizing patterns in the data than we are.
Yes.
We can maybe say it a little bit differently or generally. So let's take the fruit example. So on a traditional machine learning algorithm, you would do what we call feature engineering. You will say, okay, I think that what's important is the size, the shape, the color. And I'm going to tell the algorithm what is the size, what are all these features. But I decided what they are. When it comes to deep learning, if you do deep learning, certain kinds of deep learning at least, You'll just show a picture. You'll show a picture of the apple, and it will say, get all the pixels of the picture, and it will, over the layers, it will take out the features that it thinks are important to get to the result.
Yep.
To get. So eventually, probably it will be looking at color, but whatever else, and it's a black box to some degree. You won't exactly know necessarily what it's looking at, and that's a problem sometimes. So there are some research to try to figure out, to like reverse engineer and see what actually were the features that were extracted in this process. The routing problems and etc. Actually, I would take them outside this equation. They're not. They are the part of AI that is, from my point of view, is not machine learning or not deep learning. These are other kinds of algorithms that they adapt themselves, but they are not machine learning in a way, in classic way. You don't give them features and tell them what the answer might be. It's not. It doesn't fall under supervised or non-supervised or the machine learning types. It's
that
just
leads me to one of the other questions I had then, which is, are we seeing companies trying to implement AI where it's not needed? And have y'all seen that too much? Heard of it?
Eyal has probably more experience in this than myself, but I might be able to say a few things.
I can say that I encountered such a case. So far, whenever somebody came and told me this is a problem we want to solve, it actually made sense.
Okay.
I'm sure that there are cases where you think AI might be okay or machine learning might be okay, but we don't really have the right data, or there is no good way to achieve the data, or no cheap way to get the data, so it doesn't make sense because of that.
Okay, so the data becomes the biggest constraint, really, then.
For machine learning, at least. Yes.
Well, there is also another element here. I mean, I'll give you an example. This happened quite a while ago, maybe 6-7 months ago. I was introduced to someone, and the guy, he's like an entrepreneur, and he wants to build an app, and like he's got all these ideas, and he says, I want to use AI. So I said, like, do you have an app already? Like, do you have it functional? So he didn't even have an app, but he wants to use AI. So you see, you're already building sand castles, right? First, you have the app. Even that is like, I said, if you have a prototype, and then I also wanted to ask him, what do you want to achieve? Like, see, there are a lot of these what questions, why questions, how questions. If you don't even answer them, then AI even doesn't come into the picture, because if you haven't solved the problem. And like also, we had this, I think we had it on a conference as well. Eyal was there. Someone came on the call and says, we want to use AI in our databases, like, make our databases better. Like, that's a very high level goal, right? What do you want to use AI to do that? Increase the performance of the database, increase the ability it does the searches, increase the ability it returns the search results. You got to be more narrowed down to what problem are you solving? Actually, that is what I was going to say. What problem do you have? What problem do you want to solve? What do you want to enhance? If those questions are not answered, then the company or entity or individual is trying to use AI for the incorrect reason. So this person who was talking to me was going on with this, and I kept answering, do you have data then? Like, like of something that isn't doing that well, and you want to take it somewhere else. Then we know that that's the data where you want to target. If you don't have that, then you can't do machine learning, right? In the first instance, because machine learning needs targets. You need features, you need target. When you put them together, it's called sample data. If you don't have that, you cannot start anything. Even you cannot do deep learning, because deep learning needs even more data.
Okay.
What you describe is a more general problem, because I think last week in the conference, somebody was not talking about AI, just about Java or whatever, but people would say, okay, we're going to start this project, and we're going to use this framework and this framework, but they didn't even define yet what the problem is that they're solving. People
exactly.
have a tendency to want to use certain tools, so it obviously will work with AI. They'll do the same with AI, because this is now it has the best sound to it.
Yeah, with that example right there, I've actually, as a freelance developer, I've seen a lot of projects that I've come into where, unfortunately, it works similar to that, where the client had a particular business objective that they were trying to do, right? So they did have some kind of problem they were solving, some kind of service they're trying to offer. But the contract developer, because they only know certain frameworks or certain languages, they're like, it's kind of becomes like that. I have a hammer, everything's a nail.
Everything, yeah.
And they didn't pick the framework based on like what's the best solution for it. And that's one of the things that I've talked to many other freelance developers, like, look, if you hear a problem that a client or a service that a client's offering, and you know it's best developed in a different tool, or you know it's not good for the tool set you have, you should, by honor, pass up that job and say, hey, this is not the best for the tool set that I have, right?
Exactly.
Else you're going to try and force your own constraints on the project, and you're not delivering the best business results and all. So that, again, that's where these kind of questions came from, because I've seen where companies are wanting AI, but they don't know the problem that they're trying to solve with it,
Exactly.
right?
Yeah.
I want AI, but
Yeah.
why? For what?
Right. Yeah.
And then, so now my other question then is the inverse though, right? Are there a lot of companies that we're seeing out there that should be using AI that aren't, and
You
or
you
features that
you
could be optimized?
you're talking about those companies that I haven't caught up with yet,
Mm-hmm.
or they might be using AI, like, they must be using the old school optimization algorithms or old school logistic regression algorithms already, and they
Mm-hmm.
don't know about it. And they
Yes.
don't display it in a way, they might have written it somewhere and they don't use it, or they're doing it, but they're not telling people because they don't know it about themselves, So that is, so pretty much you can say everybody's not using AI, but everybody is using AI, right?
Mm-hmm.
Both applies, because the ones who are not using AI don't know that they're actually using AI, and that is AI, right? Whereas the ones who are using AI, they think they're using AI, but actually it's not really in the full form. They just use the if then class, and they think it's AI. So there's both of this in the paradox. If you're getting my point,
Mm-hmm.
I think
I
Eyal
will,
Eyal has something to add there.
there was a company that I don't want to say too many things, to give up out too many details, but they told me something along the lines, we were doing this thing for years because this is we are experts in this field. So we had this algorithm that was based on our domain knowledge. We understand how this works. So we would make these decisions based on all kind of rules that we extracted from our knowledge. And now, once we tried machine learning, which basically just looks at examples of this was the input, this was the output, without knowing any of these rules, it just gave us such better results that we're definitely moving to use that. We're just going to look for the best algorithm, how to implement it, how to productize it, etc. But I would think that there are many other cases like that they will soon enough will figure out that what they're doing can work better with.
Okay.
the,
All right. So one of the things that kind of made me want to ask that though is like, so I did some studying on UiPath and robotics process automation stuff, RPA, because that's a big growing field, and it's taking its impact on especially non-developer positions pretty heavily. Like eventually, RPA is going to replace a lot of different jobs, and just automation in general is having a major impact. And essentially, I feel like right now we're pretty much in the age of automation. More and more things are becoming automated, and so the question about should companies be using AI, there's a lot of instances at companies that I've worked for, and even companies that I've been introduced to, that I noticed, like, man, there's a lot of processes that you would benefit from using automation that would help streamline, cut time down, and some people hear it as a threat, like, oh God, like like accountants and stuff like that. You start coming in and streamlining their process and all, because, like, I mean, if you look at an accounting processes that they do, you can pretty much automate the whole process. It's pretty straightforward. You got inputs coming in of values, you got outputs, and you're balancing some stuff out and all. And there's some tax logic that's in there and some other parameters, but it's very known set of parameters, right? So in the data entry part, like with UiPath, I can even automate clicking on applications and moving it around and doing all this stuff to where it's not even, I don't need a person to even manually move data from one system into another. Even if there's no API to integrate them, I can use UiPath to pull data from one and type it into the other and then pass the data along like that if I don't have an API. So I was kind of wondering, like, what is the impact of like AI in this role? Like, are there, that's why I may think is like, is there companies that should be using AI because they would benefit, there'd be savings, better results, like you were just mentioning, Eyal, of a better result. The machine learning came in and was like more accurate or whatever it was, what I'm saying? It's producing better results. So, but that leads me into one of my questions is, are we do you foresee, and this is just a personal opinion I'm asking for here, do you foresee impact to jobs like automation, like it's going to replace people? Is AI, machine learning, deep learning going to replace people's jobs, or just maybe enhance them? Where do we see it going? Eyal, you want to kick this one off?
Yeah, why don't you do that, Eyal?
Well, it's definitely replacing people in certain jobs, and we'll probably keep doing it in different places. But that has always been the case, not even before computers have been around. And just as industry progresses, there are more automated processes and then robotics, etc., that took the place of people. And it will just continue happening over time, and people have to adapt to that. And I guess it will probably shift certain.
What kind of jobs do you see it impacting the most?
Good question. Like a couple of years ago or so, people thought that maybe drivers will be gone in very shortly because they have all those self-driving cars, but that actually doesn't happen the way they thought. The cars, fully automated cars, are still probably not where they thought they were going to be. You do see a lot of cars that you buy now, and then you can just, in the commercials, just hold your hands and let the car do the pass another car or park itself, but it does not yet drive by itself because it might run somebody over, etc. So what's more interesting for me is the question: is it going to replace? Are developers going to suffer from that? Software developers, where originally would be maybe the last thing you would think about, and there are. On the other hand, you can think of it another way. Right now, it looks like there are some AI tools that make it easier for a developer to write software. You can start something and it will do like a very sophisticated autocomplete.
Yeah, the IntelliSense, I love it.
There are already tools that will search. Stack Overflow will find like the best practice to do something that looks like what you're trying to do and will help you out. So, and there is even some natural language processing engines that you can tell them, write me a function that does so and so, and they will actually do that. So this might also lead to either making our life easier or making our life, or it will make us, we will need to be a lot better and more specialized, in the sense that if we just do general thing, then we would be replaced. Another interesting thing is data scientists. It used to be that, or I don't know if it's very different, but it looked like, at least to me, that everybody needed data scientists to do the machine learning because everybody needs to do machine learning. But now, because it became a commodity, there are a lot of out-of-the-box solutions. You do need the knowledge. You need to know how to apply them. But they also realize that the real expertise is, there are very few real experts or very experienced experts. So they sort of they find a way to, in many cases, to put their expertise into software. And now you have a lot of automated AI tools that can search for the best algorithm, for the best parameters, and do a lot of stuff on their own. And so in a way, it sort of eliminated actually the data scientists. So instead of needing a data scientist in every place, every developer can step up nowadays and can become, what I said before, a citizen data scientist. Will know how to use this tool, will understand enough, and then you don't need a real data scientist, let's call it, in that place. You need fewer of them, and maybe the really good ones, to mainly create those tools for everybody else. But so actually, a lot of what we used to think of more sophisticated jobs are also affected or could be affected by AI, not just the menial jobs that an assembly line or people who just copy and paste stuff. But those are affected as well, of course.
Man, yeah, anything you add?
Well, I think Eyal covered it quite a bit, and I want to introduce a couple of terms: human augmented AI or human in the loop AI, where and it's both ways. AI is being helped by humans to make better, accurate decisions, and humans are being helped by AI to do the task a lot more efficiently, because humans have limitations that AI can, supersede. Like a computer can crunch billions and trillions of numbers in milliseconds, whereas humans can't do that. Whereas humans can do very creative things, which AI is still working on, right? So, and the question of will our jobs be taken away? No, our jobs are going to transform, because if you look at it 50 or 60 or 70 years ago, when computers were not there, like how were we doing things? Using calculators, using abacus, and using all kinds of manual tools, right? Scientific calculators and all kinds of tools to help us add things and do our bookkeeping and all those things. And accounting was one of the examples you gave. Now, look at what's happened now. And every decade, we've been doing more and more of automation. So a lot of the redundant things are becoming automated and becoming seamless and becoming part of our life, and we just taking it for granted. But we are doing other things that cannot be automated, or which is error prone and which needs human intervention. And that's where the domain knowledge comes in, right? For every field. And that domain knowledge to get transformed into AI is still going to take its time. And when it gets transformed, then there'll be other responsibilities and other expectations out of those domain experts in those fields, which AI may not be able to solve at that time, and AI will be needed to assist them solve it. So this is a continuous cycle. And I was giving this example in another podcast as well, where Eyal was present as well. And I give this example, like, look at what the computer industry has done to jobs. People thought they would take away jobs, but they actually created more jobs, right? Because with a computer, all the other industries that are dependent on it, like, you have furniture, you've got printer, you've got all kinds of added accessories that's needed to help use a computer. All of those industries flourished, which means manufacturing in those industries had to be done, which means jobs were created. That means more value-added services, shops were created, industry,
just a different type of job than what was maybe before.
Exactly. And the same, and the way we write programs, way we wrote programs in the earlier days, punch cards, is not what we do today. We have more sophisticated ways of writing programs. But yes, as Eyal was saying, that we'll also have programs that take away a lot of the redundant bits that we do, like, your UiPath was an example, and make us focus on more sophisticated things, like, things that we used to write code and then and look at the results and then compile it, and then we say, okay, that's good, all the tests are passing, we'll deploy it. Rather than doing that, we'll now run hundreds of those programs, visually see which one is giving the best results for the best parameters, and configure it so that those programs run for that data. And then we deploy that program. You see, now we are writing multiple programs, we deploying them in one go, but they're all taking care of different ranges of values.
You know what you made me think about when you talk about it? So in a very recent interview, yesterday morning, matter of fact, that I had, I was asked, they're like, hey, pull up a just regular text editor, right? Like Notepad and Notepad plus or something. And so I pull it up and I'm like, all right. And there, I know we're going to go through this code challenge thing. And then it hit me how dependent I had been on IntelliJ helping me write Java code, that I had to sit there and really think about the syntax. I'm so used to, I start typing, and as long as I know the start of what I'm trying to do, it finishes out the, I can see the rest of the syntax. If I don't remember all the available functions, you just hit the dot and I'm looking, and then I can just kind of scroll through and be like, all right, that's what I'm looking for. That function has the parameters, is going to give me the return that I want. All right, that's how, and I can kind of build it like that. I don't have to memorize all these different things. But then in these interviews, it's like, it's more of a memorization test, because I can like explain exactly, well, I know I need to do this map, and then, or I'm going to filter and then map this stream, and then I got to collect it at the end, you know what I'm saying? But all right, let me write my Lambda function. What does that look like? And then I realized, because I was just programming a mean stack application, like functional, arrow functions in JavaScript are different, and streams are even a little bit different in JavaScript than they are in here. And I, realized that even though like a lot of time I have to think about it, because the tool will either be in PHP Storm or IntelliJ, and it handle a lot of that, and I don't have to really memorize it. And then in this interview, I was like, man, I'm stuck. Like, I know what I want to do, but I can't remember the syntax in Java to do it, because JavaScript's what's freshest in my mind right this thing, because of my last contract. So that brings me, let me go to my closing question, because I know we're getting close to time. So as a developer, particularly a freelance developer, how important is it for me to learn AI right now? Like, do you predict that this will be a common job requirement? Saying that, like some years ago, like Angular, React, those kind of technologies weren't there. And now like every job wants either like React, Angular, Spring Boot, like these things become so commonplace. Is AI going to become more and more commonplace as a common job requirement? Your prediction?
So I'll take a jab at this question, if I may, Eyal. In my observation, and in fact, I've been doing this for like 4 years now, but the last 2 years I've noticed things that people do in the machine learning and data science world and NLP, all of that is software engineering, actually, in a way, if you look at it closely, right? Because they have to write code that is robust, reusable, tested, test cases and coverage and all that stuff to make sure there's performance accuracy tests that keep checks and balances. So AI developers are going to be no different from software engineers, and software engineers eventually will have to learn how to write such code that is AI enabled, that is using data, because the blending between the two has already begun. And I'm already noticing that with some of the people I'm talking to, is that software engineers are talking to data scientists and machine learning engineers, but they're also expected to know data tools. They're also expected to know what are models. They're also expected to know how to deploy a model, which is used to be something only machine learning engineers would do, and follow MLOps and all that. But that is blending. Today, software engineers are expected, not in a very strict way, but if you know it, you're a better fit in a team, because you're going to be able to liaise with all these people much better, because you know some parts of their job. So if you don't learn data and machine learning as a software engineer, you may become less of a valuable person in the time to come than if you know these things, because then you're already marching towards becoming a data scientist or a machine learning engineer, or able to at least do parts of their job, and then they can focus on what is more core for them, and the software engineering bits you've covered. But of course, you need to know data and machine learning to provide them with the right solutions, because you see, data scientists and machine learning engineers, they are not per se software engineers at the core, right? They know their stuff, but they know it from a different angle. And so you becoming and there are a lot of software engineers turned data scientists, software engineers turned machine learning engineers. I mean, we already talked to Eyal, who's a software engineer turned data scientist. And I get to do some of these projects where both parts of the data science and machine learning work or NLP work is done by me, and the other part is done by the experts who come in from there. But that's my take on it. I think Eyal might want to add something to it.
Considering you went through the conversion, Eyal.
Well, I wouldn't call it exactly conversion in my case, but because I've been doing it all along, but in my day job has been converted in a way, yes. But I think that it's not. I mean, you're not going to lose your job if you don't know AI anytime soon. But it will give you an advantage if you do, or at least parts of it, and understand the concepts of it. And over time, I think it will be more and more required. It's hard for me to tell how long exactly you will absolutely need it, but it's definitely making its way to all the different fields that software is in, and it's definitely related. There is no basically the data science, AI, and ML are software engineering. There is no doubt about it anymore. The question is, how long can you ignore them and not let them in? So it will. It's just a matter of time. I can't tell exactly how much time, but it's a matter of time. And if you go into it now, I think you'll be at an advantage. So I would recommend at least learning about it, understanding the basics, understanding the tools.
So where would be a best starting point based on your experience?
Well, I think Manny has more of a one. Some of his links here have a lot of different, more varied, maybe more diverse starting points. But the one I have to offer is the AI for Java, where if you're a Java engineer, Java developer, and you want to know more, that could be a good starting point. I will have to look for the link and maybe bring it later. I wrote a small ebook that's called Low Hanging Machine Learning, techniques. So that book, and sort of, if you go through it, it's a very short book that goes over some basic concepts and some very easy to start with tools that you can use with Java, and they will get you sort of to a point that you can start doing stuff. Beyond that, there are really a lot of good classes if you want to take it more seriously. There are all kind of like MOOCs and other online classes that some of them have become classics. I think we should go to money because I think you can probably say more about that.
So yeah, I mean, Eyal did cover the parts that were important. I mean, if you follow the combination of Eyal's website AI for Java and the other URL that I shared, which is the GitHub repository of mine, awesome AI MLDL. If you combine the two, and also I've just linked Eyal's book, low hanging machine learning for Java at the bottom. You've got enough of on your plate, not for weekends, just for the whole month, maybe more, because there's a lot of information, and it'll take you from high level to low level, and that is how you want to approach it. I think the best way to keep, as a Java developer, start with Eyal's book, look at Eyal's blog post on AI for Java, and then on my repository, I just don't cover only just Java. I cover other things that AI is being implemented in, like JavaScript, Python, R, sometimes in Swift. You name it. You got to explore that repository. There's also Java sections that co-link to Eyal's book, and Eyal's written another book on genetic algorithm in Python. That is also in there. And the low-hanging fruit, I'm thinking the low-hanging fruit is also mentioned there. But if you then cover the Java ones first and then go to the AI MLDL repo of mine, then you pretty much, you're on the right path, I can say. But it's only a starting point. You got to do all the hard work of, there are some programs I've written and I've published on my GitHub repository. You got to start doing that. Take a Java application, like, the link I shared earlier, chatbot conversations. That was my very simple way of showing the Java developers, like, hey, this is an AI program called ELIZA, written in 1970s. This is what it looks in Java. Can you put it in a microservice? Yes, you can. You can put it in a Docker container. You can put a REST endpoint around it, and you can shoot it with questions. It'll come back with answers. And if you can run the chatbot application in the Docker container, you can see how it works. And I've also given an example of how you could use a Python written model, which is not ELIZA, which is a proper model. You can shoot it with questions. It gives you answers within limits. So, and then you put that in a REST endpoint and you host it somewhere. You've written an AI application. You are an AI developer. now reverse engineer that and look into how you've done what you've done. Which parts of it is AI and which parts of it is software engineering. There you go. You have the answer. Now focus on the bits that's AI and keep replacing the if then else with models. Go and build models. How do you go and build models? You can do it in Java using Tripio or DeepNets, or how Eyal has shown on his website, or you can do models in Python like the traditional way. There are various libraries, and I can help with that. And lots of links are there on the GitHub repository to do that. You make sure you have your data, you have your features, make sure you know your target, make sure you know the algorithms you're going to use to build a model. And there are very low code libraries available, like PyCaret. All you do is give it the data set, tell it the features, tell it the target. It'll compile that data across 50 or 30 or 40 different algorithms, and it'll tell you which is the best algorithm that's suited for the data you've given it, and it'll build a model for you. And not just that, it'll build you ensembles of models, which is getting even more complicated and sophisticated, which you could do and learn.
Scare nobody, man. You're getting too
And this is what I meant when I
scaring
was
people away.
What's that?
I'm sorry. This is sort of what I meant when the software can actually replace now the data scientists, because
exactly. Yeah, there is a software called PyCaret, which literally replaces machine learning engineers and data scientists. It does all the way to deploying as well. You need to write the additional components, but you can deploy it on AWS, your models. You can deploy it on GCP. You can deploy it on any other cloud service provider. And then there are also services like Wallohai. I really like their services. From command line, you can compile your whole data and host your whole model and host a REST endpoint on their service, right? From command line, right? And they've given you access to all the different cloud services under the hood. So people don't know if you're hosting on GCP or Azure or AWS, and you can host on all three. Nobody would know, but they're abstracting all of that away and giving you a REST endpoint. And then you go on the REST endpoint and you shoot your questions, you get your answers. But there's a model sitting behind it that's running on their Kubernetes network. So you see, you don't need a DevOps person, you don't need a programmer, you don't need a data scientist, you don't need a machine learning engineer. You just need Eyal, myself, and yourself. That's it. The whole world can depend on us because we can lead you to solutions that everybody else will be writing manually. But we've already told you through our books and GitHub repositories and through this podcast and many more podcasts to come on this topic if Jonathan kindly invites us again.
The three amigos consultancy right here.
We can
we'll
solve
all
AI,
your problems.
ML, DL problems. AI, ML, DL problems. All the three problems just through the links we've shown and this podcast.
All right, so I know we're at time. Yeah, I definitely think I'll definitely be asking y'all back to do a second to follow up to this, and I'm gonna do some learning on my own so I can come up with some better questions. And
Great
we can
questions,
take this, take it a little bit deeper. Because definitely, I know when Eyal came up with his low-hanging fruits in Java for machine learning, I was like, so I don't need to use Python? Because I ain't gonna lie, Python and me and Python, I don't really like Python. I don't like the way you have to write the syntax. I'm a curly brace kind of guy, and so when Eyal was like, well, you can do it in Java. He was like, I felt like it was a commercial he should do. You'd like, here it is, machine learning in Java. It's like sleek and sexy. But all right, y'all, thank you so much, and be respectful of y'all time, and definitely have y'all back. And y'all did a great job answering all of my questions. And I'm gonna do some learning and come back and try and turn up the heat on the questions a little bit, make y'all sweat a little bit.
More sophisticated questions, more specific this time. Next time, you mean?
Yes.
Thanks for having us. Really great questions, and thanks for organizing this. I really like the way you're doing it, and hopefully the community will gain a lot from this, as it's been broadcasted on all the social media channels at the moment.
All right, y'all have a good evening.
You too. Take care. See ya. Bye-bye.
Good night.
Bye.
Good night. Bye-bye.